First and foremost, greetings to all. My name is Jyotsna Tripathi from BSc third year and from Isabella Thoburn College. My roll number is 205009 and today I am going to explain what is the linear transformation is. Now, starting with the basic linear transformation, like suppose we call any function a linear transformation for if two conditions are satisfied. Suppose uh, there is a function, we have to take the transformation. T is nothing but a function. It is defined from Rn, set Rn to Rm. Now, a linear transformation, for it to be a linear transformation, it should satisfy two conditions. First, that suppose there are two vectors A and B which belongs to Rn set. Now, if we take the transformation of the sum of these two vectors, then it will be a linear transformation if the transformation of each of the vectors, we take the transformation of each of the vector and take a sum of them. If both of them are equal, then this would be a linear transformation. Also, there is one more condition. The second one is if we take a transformation of any scaled up vector, like here C is a scalar, right? If we take a transformation of any scaled up vector, then it should be equal to the scalar C times the transformation of that vector. If these two conditions satisfy, then we can say that a function is a linear transformation. Now, if we see the proper definition of the linear transformation, let's look at the proper definition. Let V and W are the two vector spaces over the field F, right? Then a function T from V into W is said to be linear transformation or linear map from V into W if transformation of scalar C alpha plus beta is equals to the C times the transformation of alpha plus transformation of beta. Now we know that for every alpha, beta, they belongs to V, and the C is a scalar and belongs to the field, right? Now there is one more thing to learn, that if V is equals to W, that is if transformation a function is from V to V itself, then the linear transformation is known as the linear operator. Now, for one more thing is that for a linear transformation from V to W, the set V is called the domain of T, right? And the W in which the image of the T are defined is called the codomain of T. Now, the linear transformation that maps every element of V onto the zero element of W is called the zero mapping. Now, what is the range or image of the T transformation? Let's see that. Let transformation is defined from V to W be a linear transformation, then the image of the T is defined as range or image of T is equals to beta belonging to W, and beta should be equal to transformation of vector alpha where alpha belongs to V. It is also denoted by Im in bracket T or R in bracket T. Now let's take an example to understand the linear transformation better. Let T from the set R2 to R3 be defined as t x comma y is equals to x plus y comma 0 be a linear map. Now, how we will be able to say that it's a linear transformation? So it should satisfy the above criteria that we have discussed. Now, since t uh, scalar c alpha plus beta, where alpha is nothing but x1 comma y1 and beta is equals to x2 comma y2 belonging to R2. Now, and c is a scalar belonging to R can be taken as transformation of c alpha plus beta is equals to the transformation of c. In the place of alpha we'll put x1 comma y1 and in the place of beta we'll put x2 comma y2. Now we take the transformation. Then in the next step, if we add the x1 and x2, then we will get that in bracket c x1 plus x2 comma c y1 plus y2. Now in the next step, we'll put the value of the transformation as given here. Now what we will get is c x1 plus c y1 plus x2 plus y2 comma 0 comma 0. Now in the next step, c in bracket x, we can also write this step as x1 plus y1 comma 0 bracket close plus x2 plus y2 comma 0. Now in the next step, we'll again convert into transformation. Then what can we write? That c times the transformation of x1 comma y1 plus the transformation of x2 comma y2. Now at the end we can write this equation as c times the transformation of alpha, because x1 comma y1 is alpha, we have taken that alpha. So c transformation of alpha plus transformation of beta. Beta is nothing but the x2 comma y2. So we have proved the condition required for a function to be a linear transformation. Now we can say that it's a linear transformation. Now here are some properties of linear transformation to look at. If a transformation of 0 is equals to 0 dash, where 0 belongs to V and 0 dash belongs to W. And the second property is transformation of negative vector alpha is equals to negative transformation of alpha. These both are equal and for every alpha belonging to V. Now the third property is if the transformation of alpha minus beta is linear transformation, then it is equals to transformation of alpha minus the transformation of beta for every alpha comma beta belonging to V. So this is the linear transformation. Thank you so much.